I'd like to call up Steve Cohen to moderate the first panel. So Steve's bio is in your event program, but did you know that Steve has used drones to lift cell phones out of piranha tanks? And he's flown drones carrying coffee and cocktails for films and events. Very cool. He is training consultant for major media concerns and appeared on TV, radio, and the web on behalf of the Drone User Group Network. And perhaps most importantly, he's developing a curriculum for Bergen County Technical Schools, and he's eagerly anticipating the launch of the first UAS training facility located at Bergen Community College.
Good afternoon, everybody. Just like to ask our panel to just briefly introduce themselves, and we'll start down on the end with Michael.
I'm Mike Schumer. I'm a retired research professor from NJIT. I'm a director of Unmanned Aircraft System research for the New Jersey Innovation Institute. One of our claims to fame is I'm the first in the state of New Jersey to have an operational certificate of waiver authorization. In January, we conducted 3 test flights from the training center at the Coast Guard Training Center at Cape May, New Jersey. David Yole, who's on the panel, was nice enough to do the flight operations for us with Zara 16. It was about a little over 2 hours of flights, and I can certainly tell you about that when it's my turn to talk.
Hello, my name is Long Fan. I'm a graduate of MIT. I've been working in the drone space for the last 2 decades. Part of the first team in the world to create the world's first fully autonomous system back in 1996. Currently, I'm the CEO of Top Flight Technologies. If some of you have been driving in around 3:15 to 3:30 and you see a drone hovering in front of the tower, that was actually one of our hybrid electric drones. It runs on gasoline as opposed to just batteries. And that flight time of that particular bird is about 2 hours and 20 minutes.
Thank you. Hi, I'm Don Sebastian, the president of the New Jersey Innovation Institute at NJIT. Our organization really seeks to span the gap between academic research and industrial need. One of the areas, which is our vertical in defense and homeland security, includes work in unmanned systems, and in particular for today's event, a focus on creating an active test bed in South Jersey where we can be not only experimenting with the platform technology but various payload technologies and perhaps move towards some sense of standards and interoperability between those two.
Good afternoon. I'm Joe Shears. I am the Executive Director of the Stockton Aviation Research and Technology Park. We are building a collaborative research facility between academia, government, and industry focused on aviation research. I'm also the Associate Director of the New Jersey Unmanned Aircraft Test Site, conducting flight operations in the state of New Jersey.
Good afternoon. David Yole, CEO of American Aerospace Technologies. We build and operate medium altitude, long endurance unmanned aircraft systems for energy and emergency management. And at our table over here, if you're interested, we can show you some imagery from a campaign we just did in Cape May 2 weeks ago, in which we flew 420 nautical miles in 2 days, offshore, onshore, and it was quite interesting event. So welcome you to come by and see us.
Well, thanks very much. I'm honored to be moderating such a well-established and knowledgeable group. So my first question, here we are talking about the future of drone technology, and a lot of us are really exposed, and daily it's a moving target. As far as what's the balancing point between legislation and innovation? Do you feel that regulation hinders innovation, or what are your thoughts on the current regulatory state in Jersey and around the country? I mean, I'm seeing legislation that's being raised here in the state, but also in the state of California, where it was recently vetoed. Do any of you have an opinion on that? Go ahead, Michael. In terms of regulation, one of the things I do,
I'm the academic advisor for the New Jersey City University Doctor of Science program in Civil Security, Leadership, Management, and Policy. I have 4 doctoral students looking at policy issues, which is going to come out with knowledge as it pertains to regulation. I have 1 student looking at policy issues from the lens of law enforcement, 1 looking at policy issues from the lens of the fire services, 1 looking at, one of my students is from the Department of Homeland Security in Washington, D.C., looking at policy issues from the standpoint of personal privacy. All right? So we're looking at this, but what we're finding is that our legislators need to be educated. If there's anything that needs to be done in this space right now, is our legislators at the municipal level, county level, state level, and even our federal officials, whether it's senators from New Jersey or representatives from New Jersey, they need to be educated, and they need to be educated with respect to good, solid research that's coming, at least from my perspective, from the doctoral level at universities. So there needs to be this education from my perspective, because there's going to be a very unique balance between how legislation will regulate, how that'll interface with FAA regulations, what kind of leeway that'll permit the innovation that's required to really take place. So it's going to be, from my perspective, it's going to be a huge balancing act, but we really need to educate legislators because a lot of them really need it.
So if I learned any lesson last night watching the debates, it's that there's a certain value in being a one-note Johnny. And for the sake of this brief panel, I'll be the one-note Johnny that keeps pointing to the importance of having a functional test bed facility to actually demonstrate these things in a real-world context before you can talk about regulating, so that when you regulate, it's around the known as opposed to blocking out a fear of the unknown. And if we can create that and demonstrate the policies, procedures, and functionality that are necessary for safe operation, regardless of the application, then you can talk about having regulation. But if you talk about it now, it's more likely to be, as you referred to, a barrier to any kind of progress, because out of fear of the unknown, the answer will be no to everything.
Thank you. Okay, so in regards to that, what is your gentleman's take? There's a lot of educators here on our panel and in the audience. What do you think of the current state of STEM education as it pertains to the coming drone economy? And speaking of that, do you feel it's being under or oversold in the media, or perhaps in industry itself?
Could you repeat that question again?
Sure. I'm asking about the current state of STEM education as it pertains to the coming drone economy.
Oh, okay. That's very interesting, because I think the people in this group would be interested in what's being done at Liberty State Park on October the 3rd, and I'll tell you why. About a year ago, I was asked by the president of NJIT, because he was asked by the Boy Scouts of America, as he was getting a STEM award based on NJIT's presence and focus on science, technology, engineering, and math. I'm setting up on October the 3rd a drone exhibition at Liberty State Park. It's going to be the first.
Michael, if I may interrupt you
flights.
just one second. If you could please speak into the mic. Yes, thank you.
Are we okay?
Just a little closer.
All right. It's going to be the first drone flights in close proximity to Ellis Island and Statue of Liberty. We did 4 test flights last week because we have permission from the from the state park services to do that. But the Boy Scout event is going to be STEM oriented. So we're going to be having, this is part of the education process and how universities can insert themselves to STEM education, not only for the Boy Scouts of America, but Girl Scouts, as well as high schools. They can provide their expertise and come up with creative ways to begin to address just STEM per se. So on October the 3rd, we're going to be filming the opening ceremonies, and we're going to be streaming that to 2 large video devices that's going to be in an outdoor stage at Liberty State Park. Then we're going to be having 3 flights using pan, tilt, and zoom and gimbal cameras in close proximity to the Ellis Island and the Statue of Liberty. Then I have the New Jersey Drone Academy, which is a very interesting group that has 3 levels of flight technology education. They'll be having static displays, and they'll be doing some autonomous flights using tethered drones. All that to show the Boy Scouts just what to expect with respect to science, technology, engineering, and math.
Thank you. Don, go
If you'd
ahead.
like, I'll try to take a crack at the back half of that question, which was, is this all a lot of hype and is it oversold? And I would say probably the other direction. I am a fan of the history of innovation, and I look at what happened in the late 1800s. Edison's contribution wasn't so much the light bulb as it was the creation of the electric power generation and distribution capacity that then put electricity in almost everything you could imagine. We are now, in spite of having computers for about as long as light bulbs existed before Edison, quote, invented them, at a point where information is now penetrating virtually every object. So this idea of the Internet of Things, if we give it a slogan, smart things, from smart thermostats to bots, to all of these things networked, connected, and back together, that really is perhaps the most exciting technological evolution that I've seen in my life. And to the extent that that can ripple back and create the excitement, enthusiasm in K through 12 that I haven't seen since I watched the space shots go up with Alan Shepard and one end of my education and landing on the moon at in high school, that hasn't been there as a way of creating excitement in the classroom about STEM. Perhaps we're not an opportunity, and because the bots are approachable, they're manageable, you don't need a PhD to run them, the kids are probably ahead of the teachers in it, but that enthusiasm, I think, can be a new fountain of excitement to bring vibrancy back to STEM education.
Thank you, Don. Okay, I'd like to ask some of our aerospace panelists, what do you feel the bounty versus spread is in this drone technology? And I think Don kind of spoke on that a little bit in terms of, I kind of feel like we're in the horse and buggy era, and the drone is the automobile. And a lot of buggy whip makers got put out of business pretty quickly when the car came along. Where do you feel that that dividing line would be? Who are the winners and the possible not so much?
Well, what's interesting about drones, one of the things that's interesting about them is the fact that they create new capabilities that didn't exist previously. So there are things you can do with unmanned aircraft systems you cannot do with manned aircraft. And so that enabling technology is a fundamental shift. So there are aviation operations that currently do things like pipeline integrity management and power line inspection, where pilots are flying small aircraft, Cessna 172s typically on pipeline corridors, with special permission from the FAA at 300 feet above the ground to look for third-party machinery on these pipeline corridors that may be digging holes without realizing there's buried pipe and hundreds of barrels a minute flowing through. That can cause $100 million of environmental damage a year. Well, it's a very dangerous task. And manned patrol pilots are killed all the time. And so there's an opportunity to save lives and improve the integrity of our infrastructure in this country, for example, using unmanned aircraft. In the emergency management regime, for example, the U.S. Forest Service, they don't fly fires at night to survey and spot fires and map their progress because they've lost so many pilots at night, it's out of the operations. UAS enable a whole new mode of operation for the Forest Service, for example, without putting pilots at risk that creates a new capability to save lives and property.
Lynn.
Hi, this is Long. So I feel that I agree with someone who made an analogy earlier to the early days of the car innovation. I feel that for drones, even though it's been developed over the last few decades, we're still in the early years of a Model T type of drone, like the Ford Model T car. So we're still in the early stages of the development of these technologies. I think that we still have a long way to go probably inning 2 of a long 12-inning game. This technology...
Are you
not
implying
just-
overtime there, Long? Extra innings, I mean?
Yeah, it's going to be here for a long time. It will be here, for the rest of our lives. You're going to see deep penetration of some of the applications that David just mentioned. You're going to see more of those type of vehicles in use for those applications. You're going to see applications that you haven't even heard of, and it's going to go deep into the economy, everything from the transportations of goods and services to someday the transportation of even people, and that's what, for example, the Google driverless car project is all about.
All right. Thank you. So this conference also speaks about the future of robotics, and so we have a fair amount of robotics interested attendees, and I'd like to ask the panel, what sort of overlap do you anticipate between robotics and drones? I've often referred to them as flying robots, and I don't see there really being that much of a dividing line, but I don't want to steer that conversation that way. But what do you think the overlap is?
Maybe I'll start with this one. So 2 weeks ago in the campaign we did down in Cape May, we actually did an integrated operation with a robotic sailboat, where we had a mesh network node on the robotic sailboat with a sensor suite, and we were actually streaming that data back through the UAS to the ground station on shore. Adding the third dimension to autonomous vehicles is a natural thing to do, and it's going to be one of the things that really drives this industry. But adding that third dimension has safety and regulatory consequences that have to be addressed. And so we're in the research phase now where we really have to understand the foundational technologies that are going to enable the regulatory framework to be developed. The fundamental technology that really needs attention today is sense and avoid, detecting or sensing and avoiding other aircraft. And the fundamental element there is dealing with what are called non-cooperative aircraft. So parachutists, balloonists, light sport aircraft in Class G airspace aren't required to have radios on board, much less file a flight plan. So how do you sense and avoid those aircraft? That's where one of the fundamental challenges lies.
Thank you. Yeah, Michael, please.
In that same vein, there's to me a very close relationship between robotics and drones because of the autonomous flight issues. We had a 4-hour white paper presentation with a group that I put together to do research in this area. Part of the team is Applied Communication Sciences, who used to, when there were Bell Labs, reside in this particular building. Another team member is Neil Messina from SRI. They're part of my team. Mark Canarino, who's developed ADS-B in and out transponders, is part of our team. What we're looking at from an autonomous flight scenario is based on a emergency management use case, where we're looking at communication relay within an area of devastation. If you take, for example, Katrina, the area of lost communication was 90,000 square miles, which means if you use that as the area of a circle and you create a radius, that means within 170 miles of a point, you can't have any cell tower communication or anything. What we're looking at is, from an autonomous flight standpoint, algorithms that will allow swarms of UASs, not swarms flying together, but swarms that will understand what the area is so that they can then displace themselves and come up with communications to do relay and provide communication to an area that's lost. When you get into that, you're getting into algorithms that'll control multiple UASs within a pre-specified area. We're going to do it small area, see how it works. Build it out, and build it out. So that's one area where robotics, I think, plays in very, very heavily.
Thank you.
When we started working this not long after 9/11, they were unmanned systems. Unmanned aerial systems, unmanned land systems, unmanned marine systems. And so in truth, there isn't any difference. The onslaught of the quadcopters that I guess are what we call, people refer to as drones, has really differentiated them as something separate, but they're not. I think the issues particularly, as you said, of scene detection and automation of response as opposed to being remotely controlled instrumentation is really the key to overcome. I think the barrier to all of them can be the lack of standardization and the inability to provide for interoperability and exchange of components. Back when cars first started, they were all custom crafted, one of a kind, built one of a kind, and even the Model T at least had progressed in an era of some mass production and some interchangeability of parts. We unfortunately have a mentality where as we start, we want to own an entire industry. Everybody wants to be the next Microsoft, but even Microsoft is not the next Microsoft. And the advances that we got in smartphone technology came when there was a reliable backbone platform, whether it was an iPhone or an Android. There are a lot of basic fundamental services that a developer can now plug into, and you can have a variety of things, and they can all coexist and make a living in that market space because they don't have to invent the phone to invent the services to invent Angry Birds, right? And I think until we can elevate the unmanned systems industry to have that same kind of interoperability, we run a danger that none of them have the critical mass of people and dollars to be able to solve all these problems all by themselves.
Thanks. Okay, so I think many of us in the both hobbyist and commercially leaning drone community are anxiously awaiting the time when there will be an actual UAS airman's exam. But I think that what many people are overlooking is the role that insurance agencies and insurance companies are going to play. And I'm wondering what you folks foresee as the industry's role in commercial operations.
But before we talk about insurance, I think we need to remember that these aircraft without a pilot want to fly in the airspace with manned aircraft. So, you know, bigger than or as big as detect and avoid and all the equipage that we talk about on the aircraft is the ability of an air traffic controller to manage the airspace that he's responsible for. Number one, he has to know that he has to be able to detect that aircraft if it's in his area. Number two, he has to be able to identify it, and if possible, to know where it's from and where it's going, and that it's whether it's on frequency or whether it's not. So a major part of what Karen's team does at the Tech Center is not the integration of what, you know, I look at it in two ways. One is you've got the UAS side of it, and the other is you've got the NAS side of it. The NAS side of this project is 10 times more complicated than finding an aircraft that has the equipment to be able to fly. Because every air traffic controller needs to come back from his cup of coffee, sit down there, and know exactly which one of those aircraft has a pilot in it. So we have to come up with all of the changes and the strategies for how we do that. And I think once we figure that out, the other issues, you know, the insurance becomes an issue, but I think it changes a little bit. We talk about cars, we try to relate this to cars. There's nobody watching every car. There's nobody telling you where to turn. Everybody's operating on their own. But in the airspace, you know, you've got 777s, you've got military aircraft, especially over New Jersey. When we flew Dave's aircraft at Cape May a couple of weeks ago, we had Coast Guard helicopters, we had private jets, we had general aviation, all of them flying in the same airspace that we were flying in. Now, the test site provides the infrastructure and the ability to maintain the safety of the airspace while Dave is doing his research with his aircraft. So it's you know, I don't want to think that we're oversimplifying, that all we have to do is come up with these aircraft that are capable and then everybody can go fly. You know, there's a much bigger problem. The FAA is spending not enough money trying to figure the problem out and scope the problem and understand how we keep these aircraft from coming together with other aircraft. I was in a panel in Arlington 2 weeks ago. The gentleman sitting next to me was a director from the New England region of the FAA. While we sat there, he got 2 messages saying that there were near misses in his area with an unmanned aircraft. One of them, a 737, had to take evasive action. So, you know, there's bigger issues here. If someone wants to fly and they're flying illegally, the FAA should still be able to see them. We shouldn't depend on everybody just doing the right thing.
So here at Top Flight, we actually work with several large insurance carriers, so I'm actually very familiar with the space. We see two roles for insurance players. The first role is as the insurer, much like your car or your motorcycle or your boat. Any of those vehicles need insurance. You would have to buy an insurance policy that covers a specified amount. I see the insurance providers playing a role in providing insurance for the air, for these unmanned aircrafts. So that's their first role. Second major role is actually as a user or a consumer of the technology. I mean, I'm sure that many of you are aware that many of the insurance carriers are looking into drone usage within their own businesses to reduce risk, to enhance capabilities. For example, Hurricane Katrina and Hurricane Sandy that hit this area. You know, the insurance carriers spend a lot of money during that time. So they see use of drones as tools to engage, you know, natural disaster and major problems when they occur. And even simple things like roof inspection to reduce risk. There, you're seeing most of the insurance carriers looking into utilization of drones to do roof inspection. So insurance companies will play those two roles, as the insurer of these devices and then as consumers of the devices themselves.
I would just add to that, just briefly, that we're able to obtain aviation liability insurance without difficulty, and it's not particularly expensive. We carry typically a $5 million policy. We have payload insurance as well, and hull insurance is now available for unmanned aircraft systems from some carriers. Certainly, the insurance market is a phenomenal market as an end use of these systems as well. I couldn't agree more.
Thank you. I want to make a point of stating that it's no accident that we have the safest skies in the world and some of the largest and most active airspace. And that's thanks in no small part to the FAA. Having said that, what do you see other nations doing that we should be paying attention to and possibly adopting?
So I work with companies all around the world, so I have a little bit of visibility into some of the activities of other nations. So I'd like to use one specific example. In Japan, I don't know if many of you are aware, but there's a big movement for precision agriculture in Japan. You know, we're talking about it, possibly using it here, but it's actually very big in Japan. About 85% of the precision agriculture work is actually being done using drones, specifically helicopter, for crop spraying, and more specifically, mostly for rice farming. You know, land use and land availability in Japan is very limited, so the Japanese, and also the labor force is very limited. So they use close to 3,000 helicopters in Japan for the specific purpose of precision agriculture. And that's one example.
Michael, yes.
Another group that did a real good study, I think it was a year and a half ago, was the Ultra Consortium in the European Union. When there was a group of organizations that studied the diffusion or integration of unmanned aircraft systems in the European Union. And they came up with what I really liked was they identified 3 or 4 quick use cases or business cases that could be the basis for integrating unmanned aircraft systems within the European airspace. What we seem to be doing in the United States is not taking a specific use case basis, but saying we're going to fly all over the place. We're not going to do that. Precision agriculture is one use case. Emergency management is another. Public safety is another. The film industry is another. Bridge inspections is another. Critical infrastructure and key resource inspections is another. You approach this from a use case basis. Then you tighten up what platforms you're going to use, where you're going to land and launch, how are you going to conduct visual line of sight or beyond line of sight, if that's even appropriate. So what I liked about what the European Union was doing was they were looking at this from a use case basis and saying from a business perspective, use case 1 is a quick win, use case 2 is a quick win, use case 3 is a quick win. You can do a search in Google on the Ultra Consortium and get all their documents. Somebody asked the question, which countries are a little bit more UAS friendly? Well, we had that discussion this morning. Canada and Australia. They're a little bit more lenient in terms of UAS type of activity. The person that's on our research team has done good ADS-B in and out testing in the Canadian airspace. Why? Because it's difficult for him in the United States to do that. All right, so I would suggest that look at the Ultra Consortium documents. They did a very nice job of studying this entire issue.
Thank you, Michael. I'd like to just ask each of our panelists, and we'll start with Mr. Yole. What would you say is the takeaway that you'd like our audience today to have in terms of the current state and the future of the drone industry?
We're in the research phase today, the early adopter phase. The first applications are being invented and evaluated and matured. Some of the technologies are beginning to approach the point where they're ready for testing in an operational environment and transitioning from research into operations. But the fundamental question of establishing a regulatory foundation upon which we can operate safely and legally is really critical. I think operating by exemption is a good starting point, and for 1,000 multi-rotors, that's okay, but what about when there's 100,000 or 1,000,000? It's obviously not going to work. We can't regulate by exception. We have to regulate by actual rules. And once we get the rules established for this below 400 feet multi-rotor quarter-mile line-of-sight marketplace that is very important emerging market, we really have to get serious about the beyond line-of-sight regulations and get moving on that, because otherwise this is going to be an industry that will only be providing services using systems sold by companies from China and elsewhere.
Of course, I go right back to the NAS. Right now, we have the safest, probably most congested skies on the planet. Any day about 10 a.m., there's over 6,000 aircraft in the air over the U.S. The idea of adding the number of unmanned aircraft that we're talking about is frightening. And it's not frightening from a spacing point of view. It's not frightening from some of the applications. It's frightening from even when we talk about detect and avoid, and we talked about having transponders, and you asked the question about a transponder for an aircraft. Having a transponder is not enough. The antenna that accepts that transponder message has to have the ability to accept that from the number of unmanned aircraft we're talking about. So right now, we're in what the FAA calls an accommodation mode. We're accommodating, by exception, aircraft by issuing them a airworthiness waiver on their aircraft. And that's what the whole process is about. So to me, the reason the FAA is doing that is because they have to develop the strategies and the equipment, not just in the air but on the ground, to be able to handle that. And that to me is really the long pole in the tent.
It's here already. The automotive manufacturers have announced by 2020, many of them are going to have commercial unmanned cars. Mm-hmm. So I would agree with you. Within line of sight quadcopters are really just an appetizer. Right? The real business are unmanned aerial vehicles that will behave just as if they are piloted. And we have an opportunity here to be on the front end of figuring out how to sort all that out, to be able to create business teams between payload and platform providers, to be able to demonstrate across a very, very wide set of terrains and applications, from agriculture in South Jersey to shore inspection, to pipeline and power line inspection, emergency response, all of these things. The compactness of our state makes it a beautiful opportunity to be able to say if it works in Jersey, it can work anywhere. So our test bed is really here to help. Come see us.
Thank you. So at Top Flight, we see three primary areas that's really preventing the market from achieving critical mass. The first is there are still technological challenges to overcome for a lot of the drones and UAV: payload, endurance, safety, ease of use. Number two is public acceptance. Is the public ready to see many drones in the air? We're ready to, when you walk outside, you don't see that many drones, but are you ready to see that? If you can imagine going to the beach, are you ready to see drones photographing you and your family openly? Is that something the public can accept? And then number three is regulatory, right? And, when are we ready from a regulatory point of view to allow drones to be more openly used? And so when we can overcome those three challenges, then I think the market's really going to take off.
Thing I'd like to leave you with is be very careful. The drone manufacturers would like you to think that you can take the cellophane off the box, give it to your kid and fly it. That's not the case. When I was at the New Jersey Drone Academy, within a 45-minute period of time, there were 3 phone calls about, can you fix the DJI? Because they were crashed. Anybody who thinks they can take this out of the box and fly it is kidding themselves. First of all, you need a modicum of education and training to do that. If you think you can look visual line of sight and fly this thing without looking at the technology and understanding it, you're kidding yourself. Case in point, when I was at Liberty State Park and George Finley was flying his 3D robotics, according to a geofence that was set up within a prescribed area that I had given him, when it took off, I would swear to God that it was flying in the middle of the Hudson River. There's a huge perception problem when you're flying a drone just using line of sight. And it's not surprising that you're going to have crashes when you do that. I even had the park police come say, you can't fly over federal property. It says, we're not. Look at where it's flying. They didn't understand. But there is a huge VLOS, or visual line of sight problem, when you're flying this. You got to be attuned to what the technology is, where it says you are, where the camera in the plane says you are, rather than looking like this. So all I'm going to say is just be very, very careful. It's not that easy to fly these things initially.
Thank you.
We're all done.
We're all done. You want no questions?
No, we're not going to have time for questions.
Okay. Well, I'd like to thank all of our panelists and for your candor and your knowledge. Thank you.